About I'm going to cover car overhead. So last time we covered divergence, which is known as del F. Then we also covered the gradient, which is known as del F. Now for today we are going to cover curve, which is the same as del cross F, which is the same as del cross F. We are going directly to an example. Which says if R equals xi plus yz plus zk, find curve of the vector R. So you've ever know that curve R is the same as del cross F. And we know that del alone equals to I times the partial direction of with respect to x plus z times the partial direction with respect to the partial derivative with respect to y plus k times the partial derivative with respect to z. And now instead of r we are having r which equals to xi plus yz plus zk. So now for me a curve which is the same as del cross F. Now we're going to put it in table form whereby we have I, Z, and K. Now for the part of here, in the I direction we have the partial derivative with respect to x, and in there we have the partial derivative with respect to y, then you have the partial derivative with respect to z. Then for r we have x, we have y, we have z. So when you are crossing, for example, you close the first part of I and you also the upper part, whereby we shall be remaining with this term. So now here, for when you reach here, you cross multiply. So there we shall be having our del cross F as it is del cross R now. It is del cross R. Del cross R as I, then we multiply the partial derivative with respect to y times the partial times z, okay, then with the partial derivative with respect to z times y. So now it will be dy z, okay. So now here it's like we are getting the determinant, so we are going to subtract minus d over dz y. Now the thing is like here we have positive, here negative, and then here positive. Now here will be negative z, and it will be the partial derivative with respect to x times z minus the partial derivative with respect to z times x plus k. Then I should be the partial derivative with respect to x times y minus the partial derivative with respect to y times x. So now, here when you are looking for the partial derivative, okay? For example, the partial derivative of z with respect to y, we shall be getting a 0y because we consider our z to be a constant, and the derivative of any constant equals to 0. So now we shall be getting 0 minus 0 minus z, 0 minus 0 plus k, 0 minus, which is the same as 0I plus 0z plus 0, which equals to 0, equals to 0. That means now here was R, which is also called the curve, equals to